Lesson 3 of Chapter 0, continuing on quadratic functions and equations. We're going to talk about the quadratic formula. You first learned about this in Algebra 2, and it's a formula. We've discussed an a, b, and a c value from an equation written in standard form, like you can see here. And the quadratic formula is listed. That's going to be something you're going to need to have memorized. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So example 6 says to solve this quadratic equation by using the quadratic formula. Well, you can see this is written in descending order, so your a value is 1, your b value is negative 4, and your c value is 15. So negative b would produce 4 plus or minus b squared would be 16 minus 4 times a times c, all divided by 2a. So that's setting it up. Now simplifying it, what I do is you have to realize that there's two terms in the numerator and one term in the denominator. So I'm going to take both those terms in the numerator and I separate them. So we have 4 divided by 2 plus or minus. We've got, let's see here, 16 minus 60 gives us negative 44. We got that inside the square root. That's still being divided by 2. And so simplifying this down, you can see we're going to get x equals 2 plus or minus. Now I'm going to break down that square root of negative 44 into the square root of 4 times square root of 11 times square root of negative 1, and then divided by 2. And this would simplify into 2 plus or minus 2i square root of 11 divided by 2. Those 2's can cancel, so we end up just getting 2 plus or minus the square root of 11i. Now these are imaginary solutions, which means that if we were to graph this quadratic function, we would not see it cross the x-axis because the solutions are imaginary. Here's another example. Now, this gets a lot of students, but you can maybe tell that it's not in standard form because the constant 8 is over on the right-hand side. So I would rewrite this in descending order. That helps you identify your a, b, and c values. Now using the formula, negative b plus or minus b squared minus 4 times a times c, all divided by 2a. So simplifying this, I'm going to break it apart. So we get negative 4 over 6 plus or minus the square root of, let's see here, that's going to be 12 times 8 is 96. And so 96 plus 16 would give us 112 divided by 6. Simplifying this, we'd have a negative 2/3 plus or minus, and then if we break down that square root of 112, I like to use factor trees. So if we do the 112, we break that apart, we got 2, we got 56, 2, 28, 2, 14, 2, and 7. So it looks like we could rewrite that as 4 times 4, or 16 times 7. So I'm going to break that apart into the square root of 16 times the square root of 7 divided by 6. So my final answer becomes negative 2/3 plus or minus 4 square root of 7 over 6. Well, that 4 6, I can reduce that, so always simplify when possible. So there's your answer using the quadratic formula. Next, on example 5, we're going to talk about a different process of solving a quadratic equation called completing the square. So in completing the square, you still have a quadratic equation, as you can see here, 1x squared minus 4x plus 1 equals 0. And to solve it by completing the square, what you're going to do is you're going to take the x squared term and the x term. You're going to group them together on the left side of the equation. You're going to take the constant, which is positive 1, move it to the other side, and leave a little space there. And now what we do is we complete the square. And we're going to create a perfect square trinomial. So in order to do that, what we do is we take the b value, which in this case is 4, we divide it by 2, and we square it. If you do that, that should give us positive 4. So I'm going to put that number in this blank. And I've just created a perfect square trinomial to the left-hand side. And now we have to use rules of algebra. If I add 4 to the left, I have to add 4 to the right-hand side. And now I can rewrite the left-hand side as x minus 2 squared because it's a perfect square trinomial. It factors into x minus 2 and x minus 2. Right-hand side reduces into a 3. And now we finish solving by getting rid of the square by square rooting both sides. The square and the square root would cancel, and that leaves us with an x minus 2 on the left. On the right we have a plus or minus square root of 3. Bring the 2 over by adding, and we'd have 2 plus or minus the square root of 3. And those would be my two exact solutions, and we did this by the process called completing the square. Here's another example solving this quadratic equation by completing the square. Same process here now. We're going to take the two x terms, the x squared and the x term, leave them on the left-hand side, leave a space, and move the constant, the negative 20, to the other side, making it a positive 20. And now we're going to complete the square by taking the b value, dividing by 2, and squaring it. Let's see here, that would give us a 16. If you add 16 to the left, you need to add 16 to the right. And now I can rewrite the left-hand side as x minus 4 squared equals 36. Now I will solve for x by square rooting both sides. Square root and square cancel. Leaves us with x minus 4 equals plus or minus 6. Bring the 4 over, and we get 4 plus or minus 6, and to our two solutions would be 10, 4 plus 6, and negative 2, 4 minus 6. So there's two examples of solving a quadratic by the method of completing the square.